Good afternoon. Welcome to the BIM Forum webinar on DfMA, Design for Manufacturing and Assembly. My name is Reinhardt with the BIM Forum and Adapt Project Delivery, and I would like to welcome you to today's webinar. We have a great panel. We have a great presentation here for you today. Before we dive into the details of that, I would like to invite you to our next webinar, which will be on November 8th. At 4 p.m. and we will talk about IFC, show and tell, what we can do with the data. This will be exciting. Dion Mould from Lend-Lease Australia will be conducting the webinar, and we are all very excited about that. If you are an AIA member and would like to claim credits for today's webinar, please put in the chat window your name and your AIA number, and we will convey that information to the AIA. I would like to introduce John Tocci, who takes it over from here, and the rest of the panel, and invite you to today's webinar. John, take it away.
Thank you, Jan. I'm John Tocci. As Jan said, I'm CEO of Tocci Construct, a CM in Boston. And I'd like to introduce our panel before you. And first one would be Clayton Lyons. Clayton Lyons is a U.S. Marine Corps veteran and the president and the founding member of Prefix DfMA LLC. He currently leads a dedicated team that provides advanced coordination services for MEP-FP systems and advisory systems and services to architects, engineers, and construction managers on the proper integration and field installation of MEP systems. Clayton leverages his extensive experience in design for manufacturing and assembly, or DfMA, for MEP systems to provide expert design services to commercial and institutional clients. Clayton's a master plumber with over 35 years of experience and expert knowledge in all major design and fabrication softwares. Next person I'd like to introduce to you is the fellow you just heard, Jan Reinhardt. He's the immediate past chair of the BIM Forum. He's principal and founder of Adapt Project Delivery. He's a distinguished industry expert and also a software provider. Formerly a program manager for virtual design and construction at Turner, he played a pivotal role in the company's early BIM implementation. With a background in engineering and management, Jan also served as a research assistant at Carnegie Mellon University and worked on BIM and mobile computing projects at Hochtief. Jan is the immediate past chair, as I said, and he holds a PhD in computer-aided engineering and management from Carnegie Mellon University. The next person I'd like to introduce is Jim Bedrick. Jim is an architect by trade and a fellow in the AIA. He has worked on 3 sides of the AECO industry, which means he can't make up his mind where he wants to be. That was a joke, Jim. I was just smiling. He is the founding principal of AEC Process Engineering and senior industry advisor to strategic building innovation. In both roles, his focus is cross-disciplinary collaboration and the technology and processes to support it. He has led the evolution of BIM Forum's LOD specification since its inception in 2010 and is absolutely essential at the helm of that great specification. The next person would be Ryan McMahon. He's a veteran of the manufacturing and design industry. Ryan is general manager of the manufacturing informed design process at Autodesk, also called MID. He brings more than 25 years of experience delivering products across the medical device, IT, and high-performance computing industries. Ryan is the general manager of Autodesk's manufacturing informed design team. Like I said, his team is currently developing new solutions to integrate manufacturing information into the building design process to help facilitate DfMA and industrialized construction. So the last person, but not least, is Rick Del Monte. Rick is the current chair of the BIM Forum and a principal with R&B Architect, a design and consulting practice. For the prior 22 years, he was managing director and national design director for the Beck Group, a large integrated design build firm. He has a keen awareness of both the design and construction aspects of integrated design and construction. Rick is also a fellow in the AIA and active in promoting an integrated approach and has served as the past chair of AIA's Project Delivery Knowledge Community. He understands the integration challenges facing the architectural community working as a cohesive team and brings that insight into the DBIA National Board of Directors. Rick is also a regular lecturer at Clemson University School of Architecture. Whew. Okay, onward. I want to reintroduce Clayton for a second. As I said on the introduction, he has 35 years in MEP system design. Clayton was doing a DfMA before it was called DfMA because he came up in the mechanical business. And he came up as a plumber and then as an early adopter of CAD and coordination and modeling. And so he would prepare cut sheets and spooling sheets in order for the designs that they were working on, or his firms were working on, to go into actual fabrication. And that started more than 20 years ago. Since that time, Clayton has set up 2 major shops in the greater Boston area and has consulted for major mechanical projects on projects as large as $1 billion across the country. So we are talking a lot about some of the case studies that Clayton has been involved in. In doing so, we want to say that this is not to highlight any one person or one firm, but this is just the best example of real DfMA that we have in and amongst us, on several of us that have worked together with him. And so with that caveat, we push on. Oh, this is me again. So this is a slide that we introduced at the BIM forum in the face of about a dozen more that talked about how badly we sucked back in 2010. And I still use it because we still haven't gotten our train, in my opinion, back on the track fully. And this is what we're talking about even today, that there's 30% waste in materials, 16% of that is actually new materials. 40% of projects are over budget, 90% of projects are behind schedule. So few projects finish at their starting budgets that it's an anomaly. So we need to get better, and this is about getting better.
So we talked at the beginning about the whole idea here is bringing craft knowledge into the design process. But isn't that means and methods, and don't architects traditionally shun getting into means and methods and traditionally think that that architects do not have the responsibility for means and methods? Another click there, thank you. This comes from the standard owner-architect agreement, the basic AIA B101, and there's the statement right there about not having control over, charge of, or responsibility, etc. Construction means, methods, techniques, sequences, or procedures. But this statement is in the construction phase services. There is no statement like this in the design phase services. So you might think that architects are not supposed to be delving into means and methods, but next. If you Google first BIM lawsuit, that quote right there, you will find an article by Nadine Post about 2011 on a laboratory building where the MEP systems were designed so tight that they could only be installed in a certain sequence. Well, the architect failed to apprise the contractor of that sequence. And about 70% through, the contractor ran out of space and couldn't get anything more in. So in following our beloved Spearn, the contractor then sued the owner because he didn't like the drawings. The owner then sued the architect. The insurance company brought the engineer in and sued him too. And you might think that this was means and methods. That was a sequence which was specifically listed in the contract above, as the architect doesn't have charge over it. But the architect, the engineer, and the contractor all ate some of the judgment. So we architects and designers are already responsible held by the courts, responsible for means and methods. And that's where we want to bring the craft knowledge in so we get the means and methods right. Next. So most of you have probably seen one version or another of this curve that shows that, overall U.S. industry, the productivity has been increasing for a long time. The productivity in construction has been declining. A couple of caveats here. One is that, first of all, it may be that we'll never get to the level of overall industry. We still do one-offs. So Boeing will design an airplane and then build hundreds of copies. So they can invest a huge amount in upfront design and making sure that every nut and bolt and electrical connection works. We can't. The economics of our industry can't possibly support that amount of analysis at the beginning. But there is a huge opportunity. We can certainly improve our productivity. There's a big gap here, and that's an opportunity for any company that does improve it. The second caveat is that we've all seen the traditional wisdom of you have cost, schedule, and quality. You can only improve two of them at the same time. You have to sacrifice the third to pay for it. But the fallacy of that is that is traditional. That assumes we don't do anything new. If you look at productivity, that's cost and time. Does that mean we can't improve productivity without sacrificing quality? NASA managed to come up with a process of doing better, faster, cheaper. That is something that we can do also. And that is where DfMA comes in, can turn that conventional wisdom on its head. Next.
Okay. So they give this to the old guy to say, a rapidly aging workforce and a strained labor market. So this is really true, and we all see it. We all know it. It's both a drain of all the experience at the craft level. Not all the experience, but much of the experience is retiring and walking off of our job sites, and we're not attracting the same type of interest from younger people. This poor guy is sitting between these two graphs and feeling pretty dismal about life. I'll let the graph speak for itself because we're talking too much and we've got to get into the meat. So this is good.
So where do we stand today? This picture is from a BIM that is created in the design phase, 100% CD level. A typical project. In my practice as a BIM consultant, I'm seeing these types of configurations on a daily basis. Nothing surprising. I'm not judging. It's or say it's someone made a mistake. This is standard of care as it is presented in front of my eyes as a BIM consultant. We see unconstructible designs, especially in the MEP realm. We go to the next slide. Here we have the mechanical room of a hospital, which was designed to some degree, but not sufficiently designed to ensure constructability at the expense of maintainability and serviceability of this mechanical room. It's filled to the top of the room at the expense of future flexibility, of maintainability, and it's a problem. And we see these types of things on a repeated basis, and it doesn't have to be that way. That design is wasn't constructible, but it's also definitely not optimized. And we are the quest before us is to see how can we optimize things at the right time when it's easy to do. And this is what we are exploring here today.
So what the heck is DfMA? It's designed for manufacture and assembly. It's the combination of two discrete standards, designed for manufacturing and designed for assembly. And it's an industry agnostic design approach that prepares and optimizes components for streamlined manufacturing. Think manufacturing informed design, which is becoming another acronym, MID. Think about looking at design through a filter at some point, earlier rather than later, about what parts can be prefabricated, what parts can be aggregated into components. How much of this work can be fabricated offsite where it's safer, cleaner, smoother, and more efficient. And you'll have captured most of the essence of DfMA. We know it every day in all of the manufacturing sectors. Now it's coming to a project near you. DfMA, I'm going to keep, even though my name's not on it. Okay, DfMA reduces design effort. When it's done properly, craft specialists infused into design in late SD at the latest, throughout design development and into CDs, help make decisions, choose parts and pieces, fittings and hangers and clips, all the things that are important that need to be in a complete design.
So this is a little example of a DfMA approach on one hospital project. And Clayton, why don't you talk about the setup that you encountered and that you improved?
Hold on, let me take myself off mute first there. So go to the next slide, Mark. We can start talking about some of the things. So we embedded with the design team on this project. It's an A&E firm. And this was the original, early SDs, late SDs, DDs. And we started to integrate with, incorporating value coordination, which is one of the things that you want to incorporate into your drawings, getting more horizontal or leaner piping system. So on this case, it's a giant plinth, a lot of curves to the building structurally, curtain wall wise and everything else. And as we were going along, we were able to remove 50% of the piping on the plinth areas, which is 3 levels, and 31 potential RFIs per stack. And then, of course, a total of, just in the plinth area, 900 potential RFIs. I want to jump to the next slide. So as we're moving along, as you can see here on the left side, we had 3 original stacks. We went with individual venting, eliminated 2 stacks, which you're seeing on the right side. So this is all before the subcontractors are on board. When the CD sets, this was incorporated into the design CD set, and that's what the subcontractors estimated off. So it created a much leaner and shop drawing ready process. Next one. That goes back to John.
Okay, so what you're seeing here is 2 versions of the Raptor rocket engine from SpaceX, version 1 and version 2. And this image captures one of the essences of DfMA. Fewer parts, leaner, fewer things to go wrong, in Clayton's language. Go ahead. So the core principles are infusing craft knowledge into the design process, like I said. Fewer parts, like we said. Aligning component tolerances with manufacturing capabilities. Let's try not to design things that can't be built unless you really have to. And then to simplify assembly, group assembly, and find a way to make it so that it can only be installed one way. Lefty loosey, righty tighty. Next. Clayton.
All right. So on this slide here, basically what we're talking about is when we can get a buildable design and we can go out to fabrication much sooner. You're assembling off-site, much safer, ideal conditions to assemble. So the results of all of that is going to be a reduced cost because labor is a third less in order to prefabricate. The quality is better. The assembly time is quicker. It's off-site. It reduces safety and injuries because we're not assembling it or dragging it around. It hits the schedule of the job and reduces that. And it also logistically works very well for deliveries within the building. Next slide.
So it really is about collaboration, not competition, especially with the design team. We're not criticizing, we're complementing and completing.
So we talk about bringing craft knowledge in early. Why is that? This is a curve that probably everybody is familiar with. It was popularized early in the century as the McClamey curve. Patrick McClamey, CEO of HOK at the time, brought it out, and this was pretty much the genesis of integrated project delivery. The whole idea is that as a project progresses, the ability to impact the project goes down. I mean, every change you make as you go further on into the project, every change has more ripple effects. It also costs more to make changes. Typical effort is we do most of the key decisions in CDs. Beginning with the IPD, we decided that we show that if you push as much of those decisions up front as possible, you can do them when the ability to impact is high and the cost is low. So now where are we taking that with DfMA, John?
So with DfMA, you're doing it even more intentionally. Another cliche that has developed is we need to go slow at first to go fast later. So we drag or we rake that effort forward. Whatever can be pre-designed whatever could be thought through, whatever can be detailed accurately in a way that doesn't have to be redone because of some proprietary system or extrusion or other part or pieces. Anything that you can do to design with good practice and as complete as possible is what we want to do, because we will improve the overall performance dramatically. So Clayton will explain to you how this differs from the typical CMGC process. Thanks,
All
Clayton.
right, so, all right, and what we have here is a chart of a normal process of coordination. CM comes on, performs pre-con. The subcontractors are bought, coordination begins. We have to wait till sign off in order to start to get into fabrication. And what you're looking at is, you're getting about 35% fabrication on this process, because during the coordination process, you're hammering out all the issues and all the problems and the RFIs and change orders. So it's just a vicious circle. Then after the sign off and fab and everything can go out to construction. The bottom is what we're performing now, where we're taking in vetting with the designers, the architect and the engineer as part of their team. And in parallel, we're creating a set of fabrication level or shop level drawings that we can go out to the subs on purchasing. So on the bottom chart, you're now looking at the subcontractors to purchase. We got a longer, bigger fabrication stage, and construction can be pulled back in a couple of months. So one of the biggest things to go out here on is fabrication. It's offsite. It's a third less of the man hours required than doing it in the field. So if we're doing a third less labor on 35% being fabricated offsite and go up to 85 to 90% fabricated offsite, we're looking at a much better going out to bid, getting the owner the price that is incorporating that 1/3 reduction in labor. Next.
Fantastic. And so as Clayton mentioned, these are really important methods, and they're used in other geos around the planet as well, specifically in the UK, Northern Europe, and the Nordics. One really strong example of using this method is Lang O'Rourke. About 10 years ago, they made the decision to commit to DfMA and stated that they wanted to achieve targets of using 70% of the design elements using DfMA as part of their process. They wanted to reduce labor by 60% and shave 30% off of overall schedules. And to the best of my knowledge, they've actually accomplished that. They built a $200 million factory in the Midlands in the UK for precast concrete panels and components. They can support a huge amount of variation of each one of these elements, but all of them follow specific manufacturing rules and have very clear constraints so that they're always known manufacturable. And in their process, their designers have to seek to use these predefined components as part of any design solution, and they have to get an exception to go outside of using those regular components. And in this way, they've achieved these objectives that they called out here. And Lang O'Rourke is one really good example, and you can see all kinds of stuff on the internet about what they're doing and see videos of their factory. But there's plenty of other examples. Goldbeck and Max Vogel in Germany are doing similar kinds of things and getting similar kinds of results. Another couple examples are Mott MacDonald and Royal BAM in the UK as well, and there's a ton all over the place. And now we're going to dig into another example.
So let's go back to the East Coast. This is our hospital project that we started to introduce. And what I want to say also here is there is no rocket science to this. This is traditional software. These are skills that are available. We just need to configure our approach, how we execute this project so that we take advantage of these opportunities. The savings that were accomplished on that particular project are significant. We've looked at that at the beginning. We'll go through here. Clayton, why don't you continue talking about that project?
And also, just so you know why Jan's talking to that is he was actually there. So one of the things, there was we saved 500 beam penetrations. There was like 800 beam pens that were required. We had this particular building has 5 different curves to it structurally and curtain wall wise, where it presented some really heavy challenges. So for fitting a dry system into the lower levels, in order to hit the beam penetrations that was, needed for it, we would have had to have about 30 drains per floor for swing joints. What we ended up doing in order to keep it straight was we mitered a 45, welded on 2 grooved ends so that we could get 1-2 degree bends and stay level and pitch. So this
let me interject here. The significance really is that this all happened at design time, right? This was at the time when you could buy beam penetrations for a penny and where you had all the flexibilities to make changes to the structure.
Correct. No structural subcontractor had been purchased yet. We're still just getting into late DDs at this point. So we're able to actually fill in some of the gap on design. So this is what ends up going out into the architect and engineer's copy into their CD set. Now we're going out to the street much leaner.
So this is what, can I just add something, Clayton?
Yeah.
And that is that this is what we're talking about infusing craft knowledge into the design process. Most designers didn't even know that they had a problem. In fact, most CMs didn't even know they had a problem. But the craft knew that this was going to be a problem because you needed drains at each one of these locations. And you're going to have a serious issue in this. But bringing the craft in, dropping it in like a parachute at the right time, solved the problem that people didn't even know they had.
In the traditional process, we will never know how expensive it is because we buy it expensive and we never compare.
Yeah. On this particular project, we actually upsized 60 beams in order to keep the drive lanes, and that was prior to the steel subcontractor purchase as well. But this is what goes out to the subcontractors to look at: the hangers, the nuts, the bolts, and then they take it and they go into installation. So we're purchasing them much cheaper, and we're also, because we're doing this, we're incorporating value coordination. Value coordination can yield much greater results than value engineering can. In this case, these are the things that we fleshed out on this project with bent plate because it was started off with curve plate. We suggested because the way the elements, the fin tube and everything that was in the curtain wall, that we go to straight 5 footers, 7 footers at each knuckle, underground piping, so total cost 4.5% upfront savings on the GMP. Next one. What did I go to soon?
Okay, we're going to talk quickly about a case study that is currently under construction. This is a Tocci project in the Boston area, about $110 million project, 250 units on 3 stories of podium with a robust program, mixed-use program underneath it. Go ahead, next slide. What happened here was piping was redesigned and rerouted. We eliminated all dropped ceiling requests and requirements, and we even eliminated bump outs in corridors and in around units. Reduced piping by 25% across 3 levels, prevented change orders, eliminated delays. In fact, the project is running 7 months ahead of schedule. We increased MEP system prefabrication from 25 to 60%. Our goal is to get it higher. And we modeled to LOD 400. And no contingency was tapped. So how did this happen? We do have a magic project, Mr. Tocci. No, next slide, please. So it's the standard spaghetti and mess and, crowded interstitial spaces. We don't need to go into the details of it, but once you go to the next slide, the difference between DfMA and regular coordination is number 1, when you do it, and 2, how you do it. It is done with the thought of optimization, not just straightening out a bowl of spaghetti. It's to question how much of that spaghetti do you really need. I realize I'm using, kind of informal language, but it really is true. So can you just go to the final slide of what happened here in this project and parts and pieces. So as on the left is what was designed, and on the right is what was optimized. Now, obviously, those are the same bays left and right, and the amount of piping reduction in these particular bays was actually greater than 50%. Now, we're not saying with DfMA you're going to get rid of half of your pipe for a properly designed project. That's not going to happen. Overall, the project, and we're showing you one of the better grouping of bays, but across the entire building, we reduced piping by 25%.
And John, one of the key elements there is the fact that on the left, they wanted to drop all the ceilings.
That's correct.
And that was a battle for a couple of months. And then we changed the underground in order to.
I'm glad you mentioned that, because that's what I was going to say. It's not just moving pipe around. It's thinking outside the box. It's bringing the craft in. And by the craft, I'm not talking about VDC, as much as I love VDC. We're talking about people that actually know how to hang pipe and actually know what you need and where it drains to and what the code requirements are for drainage and drainage area. In this particular case, the outlets were revised, the underground was revised, everything was revised and optimized. So getting rid of stuff is actually more important than putting it in the right place or a convenient place.
And the boost on the schedule.
Yes, the boost on the schedule. So this really brings up a quote that I love by Peter Drucker. Next. There's nothing so useless as doing efficiently something which should not be done at all. Next slide.
All right, this is my. All right, so this is another project that we had done down in Philadelphia, past. And if you go to the next slide, what we're going to show you is. Next slide. I want to get to the real stuff. All right, there we go. Everything that you're looking at was done early on, before subcontractors, before it went out to the subcontractors, including the steel. We took this and we coordinated it. Next slide. Stick on the next slide for a second. So what you're looking at is half the building right now is being erected. And when we brought the subcontractors on, like I said, we bought it lean, that we were able to take while the steel was going erected vertically. The subcontractor was able to use the steel crane to drop their fabs, which you see in the electrical here and the large bore pipe, on the rebar. And then as the steel got pinned and moved up, before the decking was placed, they were able to pull their fabrication in place, button it up, and then you can jump to the next one. It's just another angle.
Clayton, go back to that slide if you don't mind. That
Yep.
looks so innocent, but for experienced people, this is significant to have the pipe coordinated, know where it needs to go. We can use the right equipment. This is big, and we had the MEP coordination moved forward 6 months, and we were able to use the right equipment. We put it in the right sequence and realize all these benefits. And if we had coordinated 6 months later, all these positive ripple effects would not have been able to materialize on that particular project.
Jump to the next one. All right, you're looking at just a different view. You go to what's being installed. So like he's saying, we're quite a few months ahead of schedule, which when you move your MEPs 4.5 to 6 months ahead of schedule, you're looking at work in place, you're looking at cash flow, there's just so many different things. You're looking at the elimination of the second crane to hoist this stuff in place down the line. And in this case, the mechanical contractor paid a case of beer to the crane operator in order to move this in. So, I mean, there's a lot of things here that have been
drink
removed.
on the job site, by the way.
No, those are the go home with. Yeah.
Okay, right.
But it's testament how inexpensive it is to install it when you do it at the right time.
Everything's ready to go. All the hangers were set into the deck when the deck was getting placed. A couple slotted there. You see the electrical. So every project presents a different attack plan to make things happen. But ultimately, when you get rid of all the BS that a project has when it gets into the coordination phase, and we can get everybody hitting the ground running with shop level drawings out of design, that's the key element of getting fabrication. You can't fabricate unless you're done coordinate.
Go ahead.
Oh, next, by the way.
Ryan, start over with the mic.
Oh. You're still on mute.
I told myself I wouldn't do that. You did it. All right. So we've seen some really great examples, which has been fantastic. And I think one thing that we can agree on is that these projects are really complex and they have a ton of different stakeholders that have to work together to be successful. And really, adoption of these methods requires that everybody understands the benefits that they're going to get so that they have the right incentive to adopt this. So starting with the owners, owners benefit with better project execution, and DfMA delivers these particular benefits. It enhances budget fidelity based on more accurate information. It minimizes overall risk with leveraging craft knowledge to ensure better decisions are made. It accelerates the delivery and shortens the overall schedule. And it shifts labor offsite where you have a controlled environment with improved safety, better quality, and reduced waste. And lastly, you wind up having fewer change orders and fewer RFIs. So significant benefits to the owner. For the designers, there's a misconception that DfMA can impose constraints on designers and architects, and the opposite is actually true. When you make design choices informed by what can actually be made, when that craft knowledge is applied early, you have the most opportunity to impact the design in a positive way and change costs downstream. So it saves time, it enhances design focus and generates coordinated CDs. It reduces change orders and overall project risk, and it provides clear and accurate information to the site crew to minimize errors that happen there. Next, please. And so CMs and GCs, I'm a little dyslexic, I guess, generally benefit when design decisions are more certain earlier in the process. And so by incorporating fabrication knowledge earlier in the process, we prevent mistakes. It reduces change orders and handling costs. It can eliminate shop drawing process and reduces on-site labor by using this off-site fabrication capabilities. And it allows process and material optimization to reduce physical waste. All right, next slide. So let's wrap up here today and talk about revisiting the core principles of DfMA. So using craft knowledge earlier in the process ensures design decisions are more certain, critically important to the general principles of DfMA. And streamlining our fabrication processes to use fewer parts and reduce physical waste is also a significant benefit. We need to improve product tolerances and overall quality by taking advantage of the manufacturing capabilities that you can do different things in the manufacturing environment. We have an opportunity to take full advantage of them. And lastly, we can simplify and accelerate the site assembly processes. All right, so that's our core principles. Next slide, please. So how do you make this actionable? Like what can you take away from the information that's been presented today? First off, you can learn more. There's a ton of information written about DfMA, industrialized construction, modern means of construction, if you're looking at a European approach to this. And I posted a couple of links here of things that I thought were pretty compelling, but there's a lot more out there that you can dig into and learn more about. Secondly, review your current processes. Where do you have repeatability? Where can you bring your craft knowledge and introduce it earlier in the process? And how would you do that? And when you're using offsite fabrication capabilities, what could you change if you could scale, if you could reduce your waste, if you could improve your processes? How would that impact your business? It's worth going through that thought experiment to understand how this could impact your business positively. And lastly, just try something, apply it to a small project or benchmark a new project against a previous project with a new method and prove it to yourself. The benefits are significant and it will be obvious when applying these new methods of the benefits that you'll gain. All right. So that concludes the main part of the presentation. We want to provide a teaser for the second episode in this event, where we'll be talking about DfMA techniques, the software and tools, and application of these techniques going forward. All right. So, and what we will be talking about is how do we apply these methods to different kinds of project methodology, different kinds of offsite fabrication and prefabrication? How do they relate to industrialized construction? And then we can also explore, next slide, please, the breadth of application. How do these methods can be applied across everything from timber-based construction to creating exterior wall panels in a factory and everything in between. And we can talk in a little bit more detail about what that means for our customers. All right. So next slide, please. So that concludes the presentation. I want to take a moment to thank the panelists today for their time and sharing their expertise with everybody here today. And I'd like to thank each of you in the audience for spending an hour of your time with us today. And now we're going to open the floor for questions.
Just before we do that, Ryan, we wanted to just make a final statement, closing statement. We believe that the proper understanding and practice of DfMA holds the greatest potential for improvement in our collective performance and professional enjoyment that we've seen over the past 25 years. And DfMA is the logical next step in the full and respectful collaboration between designers and makers. This is an opportunity to take the skills that we've learned over the last 15 years with modeling and collaboration and IPD and cooperation and take them to the next level of returns for clients. Thanks a lot.
All right. Thank you, guys. So let me just go through some of the questions that we received here, because I think we have some interesting ones. How do you do such advanced coordination without subcontractors or suppliers involved in the design process?
All right. That's my background, and that's the team's background. We come from installation. I'm a local 12 plumber. My guys worked in the same shops, so we're doing the same thing just up front that we used to do working for the shops that we work for.
So Clayton, let me follow up on that question. Once you do this initial design that you do with the design team, your assumption is that these subcontractors can add no value to your optimization. You've optimized it. You go to them and you say, just build what's on the drawings.
They're our peers. They're no different than we are. So yes, we've been doing this for the last 13 years, and I've been doing it for 25, where we're handing it off to subcontractors. We do give them an option for the liability purposes to take on. They have to take ownership and do their own sign off, so they do get a chance to make their adjustments, because you can't force them to put it where it is, but tell us why it can't go where it's going. We've had that issue. We've gotten over it in the territories that we've been working in. We've had no problems with the subcontractors.
If I could chime in a little bit on this, I think the answer to that question, Rick, is you don't. That knowledge of the subcontractors, whether it's whoever it is that provides that knowledge, the knowledge of the subcontractors needs to be there. As Clayton pointed out, he was one for a long time. He knows how to hang pipes. Oh, we still install too, yeah. Yeah, I mean, you know how to hang pipes, yeah, as John pointed out earlier. So you're not going to, you can't do this kind of coordination without getting somebody involved who knows how to hang pipes.
And what's required for access. But go on, because I'm jumping out in 2 minutes.
Okay, so in the hospital example, was the model part of the design team's required deliverables once you put out all that intelligence in there? Yes, so the architect turned it over and took responsibility for
it. So the architect at that time, and Jan was at that project, we completely embedded with them. And it wasn't our first job with them. They're an A&E firm. They're very good. And we just, our relationship was, here's the access I need to get a weld on so I can run a bead around the pipe. I need to get 2 guys up there. Why don't we get this in the shop instead and then hoist it up before we hoist up the duct or whatever the case might be. But our process is thinking as the foreman, straighter is greater for every trade, but straighter is greater for every trade. If there's a cheaper, I'm not going to move a 6-inch weld for, yeah.
Like, this is not about welds. This is about whether the architect is willing to take full responsibility for a set of drawings for manufacturing that they're putting out.
Yes, the layout.
Yep.
And
they did.
They're CD set, yes.
And there was a lot less resistance, no resistance. It was fully embraced, and that was quite surprising. And I think there is a lot of fear that is unfounded, and we just need to start asking the questions, and we will be surprised how interested the parties are in exploring this.
I think John pointed out earlier that this really is a mindset, and it's a matter of the involvement of the craft knowledge does not compete with the designer; it enables the design. So I think that's a really important point, that it's a mindset that everybody has to go into the project with.
It'll take some time. It'll take some time.
Yeah. Would you consider, by the way, part of lean design construction?
Absolutely. Absolutely. This is taking lean to the edges.
Okay.
Good edges, really good edges, I think,
Can target value design enhance DfMA?
Yeah. I don't know if somebody else wants to answer it, but absolutely target value design can enhance DfMA. That's why it's so important to have all of these voices in, and when the design is in robust creation, the more informed voices, the better.
That's all the questions we have formally, but I would ask one. As I'm practicing somewhere, I don't have access to Clayton. How do I go about this?
That's a really good question. It's a really good question.
I think, Rick, you could probably answer that. I mean, you've been all your professional life, you have been pulling craft knowledge into design projects in one way or another. And I think one of the important points here is that this is a technique. It's a mindset. It's a process. It does not. It's not limited to a certain kind of project delivery. It works in design build. It works in IPD. It works in CM at risk to a certain extent. Doesn't work very well in design bid build, but a lot of things don't work very well in design bid build. But I think that the knowledge, the craft knowledge is out there. We all have access. Anybody in the community has access to the design knowledge and the craft knowledge. We just need to bring it together with the right mindset.
I see this as a call for action to the owners. The owner is the only one who can pull something like this off. We have an opportunity to educate the owners, but the owners need to spend the money to pay for the craft knowledge that is moved forward in the project delivery process. And this is where the opportunity lies, and this is how I would propose to approach introducing DfMA to more projects, that we educate owners about the opportunities that they have been missing in the past couple of years, and that it's real, it's happening, it can be done. It's not rocket science. It's very traditional tools. It's very traditional skill sets. It's just slightly differently configured on our project so that we move things forward. And it's really a call to action for the owners to start exploring these things.
Well, I think it's a good point. It's a call to action for CMs as well, and designers. And it may be actually a call to action for the mature workforce that is retiring from job sites, where they may not want to be lugging around cast iron, but their knowledge is essential. And if there's a place for consulting early in design practice where people can use that deep embedded knowledge for the good of the entire team, we will probably be calling people out. We think that we're looking into the face of a new discipline.
Yeah.
Can I add to that? One of the things I think is interesting when you look at what's going on in other regions, it's about creating the incentives to work better together. And when you look at a company like Langer Rourke and Goldbeck and others, they have chose to vertically integrate so that they have more control over the incentives of how people are working, how they share information. That's kind of interesting. And then the second point that I would make is when you look at the UK and you look at Australia, the government is getting involved and saying, hey, when we want to build schools and we want to build libraries and housing, they're putting standards in place and incenting a change in behavior to kind of adopt more of this methodology, which is really kind of interesting.
Yeah, I would say, as a design architect, what I would add about this thing is that what I find appealing about it is not every part standardized, but if you can save a lot of money on the mechanical, on the plumbing, on all those core systems that are so hard to save money on, and then you allow me to do custom extrusion on the exterior walls or better marble in the lobby or whatever, and I would think that if for a designer, that would be very appealing.
Right. I find it very interesting that Langer Rourke prescribes so much of their process, but they work with some of the best designers in the world. They work with Foster. They worked with Zaha Hadid while she was alive. They built beautiful buildings and made beautiful buildings happen in an efficient fashion.
So, Chad, we've got one more question from Chad. It says, fundamentally, getting additional input on constructability and efficiency at the earliest phase of the project is key, before floor-to-floor subs are finalized. But this comes down to those seasoned craftsmen that have seen a lot. The pathways to get them pulled in early is not clear. Ideally, it should be part of a pre-con effort, but that's typically light budget, cost schedule only, not the great topics discussed today.
Well,
Hence the owner involvement.
yeah. I mean, I think that in Clayton's business and in our business, in Prefix, the optimal position contractually is alongside the design team and contracted directly with the owner. I realize that there are few and far between of those kinds of qualified consultants able to do that, but that's where it really shines the most.
So let me ask you, John, as a construction firm, do you also look at creative ways to get the subcontractor involved early?
We do, but you've got to be realistic when you're calling on the resources of a key and very busy subcontractor. Are they going to want to take some of their most precious resources, which are the folks that do the modeling and the project layout and all the thinking and the planning? Are you going to ask them to break free with some of their most precious resources in busy times? And the answer is you just can't ask them to do that. Even if you pay for it, you can't pay them enough on an hourly basis to do it. Thus, I'm arguing your side of the equation.
We had a client that did a lot of lean design, and he would give target value design, and he would bring in the subs. He would give them a budget. He'd say, show me how much value you can add for this budget. And if they added the value, he would pick one very early in the process. You've got the job. However, if you go over this number, then I have options to go back into the market. And once they're on the job and they're working to keep the job, he got very good results and very good input at the same level that you're talking about from those folks.
I think that can happen, Rick. I think it's all about relationships, and different markets and different cultures prevail in different markets. But that's certainly an option, and we've done it before.
Yeah. Okay. Any final comments for you guys? Anything you want to finish up with?
Sure, I could make one, Rick. Sean mentioned earlier the idea or I think it was you, Rick, that mentioned being able to put some of the resources toward custom parts, if you can make the standard parts cheaper. An interesting quote from a paper by Lang O'Rourke. Lang O'Rourke's early involved in a range of exciting and innovative and new manufacturing opportunities that design teams can access ahead of the pack. As manufacturing technology improves, so does the flexibility to deliver more bespoke products and assemblies. So it really, it enables the customization. It's not really talking about reducing everything to off-the-shelf parts. It enables that customization.
Yes.
Yep. Chad, we're going to be chewing on your question. It was a good one. How do we, and that gets to, how does this thing scale?
Okay. Well, gentlemen, we're at 1:59, so good job. Thank you.
Thank you very much.
Thank you.
All right.
Bye-bye all.